Hi, my name is Harrison Chase, creator of LangChain, a framework for developing LLM applications. Today, I'll be talking about evaluation of LLM chains and agents. So today, I'll cover an overview of LLM chains and agents. What are they? Why are they interesting? Why are they useful? Then I'll talk about why evaluation of these chains and agents is hard, primarily due to two main reasons: lack of data and lack of metrics. I'll then discuss a few potential solutions that are emerging as best candidates. And then I'll talk about offline and online evaluation, which are just two concrete representations of applying these solutions for evaluations to the problem at hand. So first, an overview of LLM chains and agents. The core idea of this is using an LLM as the reasoning engine. So we'll use the LLM to determine how to interact with other sources of data and computation, but crucially, we will use those sources of data and computation for their knowledge rather than using the knowledge that's present in the LLM. We'll use the LLM more as a reasoning engine. And so the canonical example of this is retrieval augmented generation. And we can think of this as a chatbot that can answer questions about particular documents. So documents that are proprietary to you that the language model, GPT-3 or whatever, has not been trained on. And so the general flow for this type of application is first you'll have the chat history, which you'll condense into a standalone question. And this is important because you'll use that question to retrieve the relevant documents. If you don't do this condension step, then you might retrieve and you only use the final chat message in the chat history. It could be referencing things prior that you won't know about. So this condensing step is really important. So you do that, then you look up relevant documents and you get back a list of relevant documents, and then you pass this to a language model to generate the final answer. And so this will take in the original question, the chat history, the retrieved document, which the prompt will generally ground the response in, and it will generate a final answer. And so here you can see that we're using the language model as a reasoning engine, which takes in a question and some data and then reasons about an answer relative to the data that's been provided. But we're basing everything, we're grounding everything in that data that we've retrieved. We're not using the knowledge present in the language model itself for that. So why is evaluation of these types of applications hard? First, it's due to a lack of data. So unlike traditional problems in machine learning, you generally don't start with a data set. You generally start with an idea, a problem or an application that you want to build, and then you start building and then you need to evaluate it. And you don't have the traditional machine learning training data set to start from. It's also unclear for this what the data set would even be. So for a lot of these questions, if we start to think of some of the more complex ones, they could be constantly changing based on the day. So a lot of question answering applications have to do with up-to-date data. So it's unclear if there's even a ground truth answer that remains constant over time. So it's really challenging to gather data. The other issue is a lack of metrics. So it's hard to even evaluate with your eyes. So a lot of these applications, if you think about the chain before, there's three different steps. It could be going wrong at any of those intermediate steps, and you might not necessarily know which one and where. And then it's also tough to evaluate quantitatively with metrics looking at the final answer. So in the question or in the example above of a question answering chatbot, the final answer that the chatbot gives is free-form text. And so it might have a particular fact in it, and that's the thing that we should be evaluating, but there's a lot of conversational text around it as well. So you can't do things like exact match on that text, and you need to do some sort of more advanced things, which we'll talk about later. So some potential solutions here that are emerging as best practices. First, around the lack of data. There's two things here that people tend to do. One is generate data sets ahead of time. And so you can generate these programmatically, and oftentimes a language model is part of that programmatic generation of these things. So in the example of question answering over a document, if you want to generate a test set for it, one chain that we commonly use to do that is a chain that splits the document up into chunks, and then for each chunk, you ask the language model to generate a question and answer pair, and that becomes kind of your test set for this application. The other thing that is commonly done to gather this data is just accumulate it over time. So if you have a application running in production, you can keep track of the inputs and outputs, and you can start to eventually add these to a data set and grow that data set over time. For lack of metrics, the first and most important thing is just to make it really easy to inspect visually what's going on. So what are the inputs and outputs at each step in the chain? What are the inputs when it finally goes to the language model and it finally comes back? This is really important for understanding if the application is messing up due to a lack of retrieving the right information, or it's retrieved the right information and it's just not synthesizing it properly. Another thing that we can do is use a language model to judge whether the final answer is correct or not. So this will handle the cases where there's a fact, but it's surrounded by a bunch of conversational text. And so we'll use the language model to take a natural language answer and then a natural language ground truth label and compare whether they're semantically equivalent. And then the final thing that we can do here is we can just gather feedback directly or indirectly from users. And so I'll talk a little bit more about this during online evaluation. But first, offline evaluation. So the main way to evaluate chains and agents in an offline manner is create a data set of test points to run against. You then run the chain or agent against them. You then visually inspect them. So you can look at the inputs and outputs at overall at each step, see how it's doing. And then that's not really scalable, of course. And so then the next thing to do is use a language model to auto grade them. And you can either fully trust this auto grade, so you could have it assign correct or incorrect to each run and then just average that. Or you could just use that as a way to guide your eyes to the data points that might be most correct or incorrect, and then do another visual inspection on top of there. An offline evaluation is usually used before the model goes into production. So this can be right after you've finished developing it, and you're doing a final test to see whether it's ready to go in production. Online evaluation, on the other hand, is after the model has been deployed. So now it's running in production, you're serving users, and you want to make sure that it's continuing to do a good job. And so the main method of doing this is gathering feedback on each incoming data point. So there's ways of gathering this feedback directly. So you could add a thumbs up or a thumbs down button to your application, and then users can click on it, and you can track this feedback over time. And if you release a new version of the application, or if the model starts doing poorly for whatever reason, you can hopefully notice a downtrend in this feedback, and you can use that as a mechanism to know that you need to fix your model. There's also other forms of feedback that can be more indirect. So if you're serving up, relevant links, if someone clicks on a link, that probably means you did a good job. If they did not click, then that means that the model might not be doing a good job. And so you can use this as an indirect measure of feedback. And both of these, the idea is to track these over time, and you can start to notice when the model performance starts to degrade. That is pretty much it. Evaluation of these applications is a new and exciting topic. These applications are just starting to kind of like go in production. So there's just starting to emerge kind of like a set of best practices around them. And I'm sure we'll continue to add and grow our knowledge about evaluation as more and more go into production. So I'm personally really excited to see what develops over the next few weeks, months, and years of running these LLM applications in production.